Show that this series converges uniformly in this given interval. That is the infinite series on cos of 2nx divided by 2n. So we are going to apply here the Dirichlet test. This series can be written as the product of cos of 2nx and 1 divided by 2n. So that we can consider this to be our unx and this to be vnx. To apply the Dirichlet test, so let unx is equal to cos of 2nx and vnx is equal to 1 divided by 2n. So for the first condition of the Dirichlet test, this vnx should be the decreasing sequence, right? And should converge uniformly to 0. So clearly, the sequence vnx, that is equal to the sequence 1 divided by 2n, is a decreasing sequence of positive terms, and vnx is equal to 1 divided by 2n. It is converging to 0 as n tends to infinity. And because this vnx is independent of x, so it is converging uniformly to 0. Since vnx equals to 1 divided by 2n is independent of x, therefore the sequence vnx converges uniformly to 0 on the closed interval ab. Again, for the second condition of the Dirichlet test, that mod of summation on urx, where r starts from 1 to n, this mod should be less than equal to m. Now what is unx here? It is cos of 2nx. So urx becomes, it is the summation r starts from 1 to n on urx, that is cos of 2rx. So when we open the summation, we get for r equal to 1 we get cos of 2x, plus for r equal to 2 we get cos of 4x, so on up to cos of 2nx mod. And according to the formula we write this as cos of the first angle, that is 2x, plus the last angle 2nx divided by 2 into sine of 2nx divided by 2, that becomes nx, divided by sine of 2x by 2, that becomes x, and the mod as x is greater than 0 and less than 2 pi. As x is greater than 0 and less than pi. The interval is given to us. Now because we know that mod of sine of x always less than equal to 1 for all x belonging to the real numbers. So I can write the mod of the numerator to be less than equal to 1. So this is further less than equal to 1 divided by mod of sine of x for all x belonging to the closed interval ab. 1 divided by mod of sine x, that becomes mod of cosecant x for all x belonging to the closed interval ab. Let's take m to be the supremum value of mod of cosecant x for all x belonging to the closed interval ab. Then the left hand side, that is mod of summation r going from 1 to n on urx, is less than equal to this m for all x belonging to the closed interval ab and n belonging to the natural numbers. This is what is needed to be proved for the second condition for the Dirichlet test. Now both the conditions of the Dirichlet test are satisfied, so we write that therefore by Dirichlet test the given series is uniformly convergent in the given interval, that is 0 less than a less than equal to x less than equal to b less than pi. Alright, thank you.